Prime Minister Modi has laid the foundation to transform India into a semiconductor powerhouse.
हमारे लिए टेक्नोलॉजी देश को आत्मनिर्भर बनाने का प्रमुख आधार है।
For a nation aspiring to lead, it must control its technological destiny.
In 2020, the Indian semiconductor market had a market size of about $15 billion, and as per experts, this could grow to $65 billion by 2026. This surge is all thanks to the essential role that semiconductors play in creating electronic devices. India rocks when it comes to designing semiconductors. Big shot companies are doing some incredible work, crafting super advanced chips with global applications. But there's a twist. Once the design part is complete, they are sent to countries like the US, China, South Korea, or Taiwan for manufacturing. Now, here's the question. With India's design superpowers, what's stopping India from manufacturing those chips in-house? So, let's rewind a bit and dive into the history of chip making in India. Back in the 1980s, the Indian government decided to start a homegrown semiconductor manufacturing unit. The results didn't really match the grand plan. Let's delve into that story a bit more. Think back to the 1960s and 70s. The US and other Western countries started outsourcing semiconductor making to Asian nations. In fact, Fairchild Semiconductor was interested in setting up shop in India at one point. But due to politics and red tape, they went for Malaysia and the Philippines instead. As technology rocked the 70s and 80s, India got serious about making semiconductors. This led to the birth of a state-owned group called the Integrated Device Manufacturer, the Semiconductor Lab. In 1976, the Indian cabinet gave a thumbs up to creating the Semiconductor Lab, SCL, which got rolling in 1984. This was a smart move to design and create top-notch electronics. The government poured about $40 to $70 million into setting up SCL in Punjab. Back then, Punjab was turning into a tech hotspot, with cool companies like Punjab Wireless Systems and Punjab Communications Limited. SCL teamed up with experts from IITs and the Indian Institute of Science, and in 1984, they started making 5-micron chips with fancy CMOS tech. SCL kept growing. They teamed up with Rockwell, a big American company, to produce their 2560G microprocessor. This showed off SCL's versatility in the chip world. But that's not all. SCL went even further, collaborating with the Japanese giant Hitachi. They worked on making components for Hitachi's electronic wristwatches. And guess what? SCL didn't just stop at chips. They even pitched in with third-party assembly work for brands like the BBC, where they helped create the Acorn computer. This was part of India's Computer Literacy and Studies in Schools program, showing how SCL supported tech initiatives in the country. Oh, and the people at SCL got an awesome opportunity. Those technology agreements meant they could jet off to the US and Japan for some hands-on training. And they didn't keep all the knowledge to themselves, they shared it with the whole company. SCL was on a roll. They joined forces with universities, supercharging their skills. They went from 5-micron chips to an impressive 0.8-micron process by the late 80s. That's impressive, considering industry bigwigs like NTT, Toshiba, and Intel also reached this milestone around the same time. India was really stepping up, with people believing we could be a global player in the next decade. So, SCL kept growing. They teamed up with universities, pushing ahead from 5-micron to a super cool 0.8-micron process by the late 80s. To put it in perspective, industry giants like NTT, Toshiba, and Intel hit that 0.8-micron mark in 1987, just a bit before SCL. Even though we were a tad behind, people believed India was on track to shine in the chip world. But then, in 1989, disaster struck. There was a huge fire at SCL's Mohali facility, and nobody's quite sure how it started. Production halted until 1997. Those 8 years were crucial, with technology making leaps and bounds. Big players like TSMC and Samsung took the lead while we were out of the game. These big names are careful with their tech secrets, making it tough for SCL to access the latest innovations. By 2005, SCL came under the Department of Space. This led to a makeover, focusing on research and development. And in 2006, the semiconductor complex became the Semiconductor Lab. Today, in 2023, it's part of the Ministry of Electronics and Information Technology. While all this was happening, there were plenty of attempts to set up chip factories in India. But they didn't quite hit the mark. Back in 2008, Mukesh Ambani's Reliance Group planned to invest over 30,000 crore rupees to build 2 chip plants. 6 more companies, including Videocon Industries and Titan Energy System, jumped in. They wanted to make all sorts of stuff, from silicon to chips, solar cells, and more. Then, in 2015, the Reliance Anil Dhirubhai Ambani Group talked about starting a chip unit in the Pithampura industrial area. Fast forward to 2012, India set aside 20,000 crore to attract global electronics manufacturers to set up shop here. In 2014, Gujarat picked Prantij for a new semiconductor wafer fabrication facility, with an investment of around 22,000 crores. The government chipped in 6,000 crores and earmarked 1,000 acres of land for this project. There were some big attempts, too. One with Hindustan Semiconductor Manufacturing Corporation, ST Microelectronics, and Siltara to start a semiconductor unit. The budget? A cool 25,250 crore. And another project was announced by the Jaiprakash Associates, in association with IBM, USA, and Tower Jazz, Israel, to set up a fab in Greater Noida. The cost? Around 26,300 crore. Both these fabs could have put India on the map, generating thousands of jobs. Sadly, despite all these efforts, none of these dreams became reality. So, India is still grappling to find its place in the chip manufacturing club. But why? What's holding India back from becoming a chip-making powerhouse? It's a mix of things, really. First off, we missed out on a golden opportunity. Back in the 90s, India focused on software and IT, stuff that made a lot of money with minimal investment. So, chip making wasn't a top priority. Later on, when chip demand shot up, we realized we needed to catch up. But starting from scratch was no walk in the park. Money is a major hurdle. Creating a chip factory is super expensive, costing anywhere from 40,000 to 80,000 crore. And it's not just about setting up, constant upgrades are needed. You have to stay ahead, improve efficiency, and keep investing. But that's a risky game. It might take 15 years to break even, and you might even end up shutting down. Tata and Reliance, 2 big Indian companies, are shying away from this due to the high stakes. Resources are another snag. Making chips needs clean water, constant power, top-notch silicon, skilled workers, and boatloads of money, billions of dollars, actually. You need pristine clean rooms because even a tiny speck can ruin a chip. Keeping these super clean standards in India is tough. Similar challenges exist in making generic drugs, where Indian companies have gotten into trouble for quality issues. Chip making needs even higher standards, and India is still catching up. Countries like Taiwan, South Korea, and the US started this way back in the 70s, training a workforce for decades. India's behind, but there's hope. You know, it was easier for the West to turn to China or Taiwan for chip making in the late 90s and early 2000s. But things have changed due to trade wars. While foreign companies could choose India, they don't fully trust our systems and expertise. It's more convenient for them to go to China directly. Another main reason is knowledge, which is a big challenge. Our engineers are amazing, but they need specialized training for chip making. Designing isn't enough. You need to build chips. We're good at design, like making blueprints, but making actual chips is another story. Also, geopolitics play a major role. If countries are friendly, they share tech and collaborate. But if not, they can limit access, slowing down progress. The US and the West were way ahead in chip tech, and they control the most of it. They can stop the sale of equipment or licensing to certain parties. This control can affect who produces chips, like how TSMC stopped selling to Huawei or ASML stopped selling to China. So, what's next for India? We need to focus on chip design and manufacturing. We need more engineers trained in chip design, building a strong foundation. We can facilitate everything that is required for new startups in this space and create a supportive ecosystem. Initiatives like building a gallium nitride fab at IISc Bangalore show potential. India is also trying to attract global chipmakers with incentives. India is working hard, modernizing places like the semiconductor complex. The government is investing in research, like the $2 billion grant for SCL to conduct advanced research and development. Intel has also announced to invest $20 billion in India, which shows how serious they are about manufacturing in India. Despite challenges, India is determined to shine in the chip world. The Make in India initiative is all about this. Demand for chips is skyrocketing, and India wants to meet it. The government is partnering with companies like Micron to set up facilities. Foxconn is exploring partnerships, and HCL and Tata are joining the chip-making party. So, what's the takeaway? India's on the move in the semiconductor world. While there are hurdles, the country is making strides. Let's keep our fingers crossed for success. If you enjoyed this video, give it a thumbs up and subscribe for more engaging content. Thanks for watching, and see you in the next one.